Can we start? Okay. So it's time to start the APNIC technical session number 4. So this is the final technical session here, APNIC 54 conference. So I'm a co-moderator, Masataka from JPX with Archie. Thank you. Thank you very much. So yeah, thank you. So and we have 4 nice presenters in this session. So the first presenter is Philip. So Philip introduced the project led by EuroIX. So it's for peering community. So yeah.
Shall I stay here or walk around? There's a step here. Do I want to use the step here? No. Sorry, we need some frivolity on a Wednesday morning. Okay, so good morning, everyone. I just want to quickly share a project that EuroIX, which is the Internet Exchange Point Association in Europe. Just a little project that's underway. I've been talking about this in some of the network operator groups over the last few months around the region. It's not trying to market or sell anything. What we're trying to do is really promote an effort by the exchange point, exchange points in, well, it's more than just Europe, it's exchange points and the peering community worldwide, but really documenting a lot of the things that I suppose we already know. I mean, some of the things I know from a lot of the BGP work and so on that I've been doing for the last, goodness knows how many years, 25, 30 years. There's a lot of things that we take for granted. So those of us who are running networks, we know how to configure BGP, we know how to go about peering with things, we know how to find our best transit providers, we know which exchange point to go to because we've been doing it for years and years. The problem is, we know it because we've been doing it for years and years. What about newcomers to the whole ecosystem? And, you know, the internet keeps on growing and growing, the more and more operators taking part on it. Definition of what an operator is has been changing from what it was probably in the 90s when at least I first started getting involved in all of this. So that's really where the Peering Toolbox project has come from. So this is kind of really explaining where we're at. So 20 years or so ago, the model was the very traditional model that we all know. Was basically, we had the internet service providers, we had the whole hierarchy of the access providers, regional, the tier ones, and so forth. And if you wanted internet access, you would connect to probably an access provider. If you're slightly bigger, you would go to one of the regionals and so forth. But you went to your internet service provider for that. Now, for the U, I mean, all the end user organizations. It could be enterprises, could be universities, or universities go to the National Research Network, corporates, government networks, websites, content providers, all connected to the ISP. I mean, you must remember in the old days, we didn't have the global infrastructure with all the big content providers. It was one website sitting somewhere, and that was where they all started. So that was very much the traditional model where enterprises or these organizations who wanted internet access would basically go to the local ISP, and ISP takes care of everything. But this has changed. And what's happening today, well, not even today, what's been really happening over the last 10 years or so is that more and more of the end-side organizations are now taking care of their own destiny. They're no longer outsourcing everything to an ISP to take care of their connectivity. They're starting to turn up at internet exchange points. And you're turning up with a fiber optic patch lead and go, where do I plug this to get internet? So the model's changed. They don't know what has to be done. We haven't documented what has to be done. And I even remember, even doing a lot of the BGP work. Oh, Philip, nice workshop and so on. Where's the book? It's like, there isn't really a book. Well, you need to write a book, and then we can't do that. The whole thing is moving so fast. Best practices are improving, changing all the time. And so there's nowhere really for a lot of these people to go and try and work out what they have to do to take care of their own internet access. So really what the problem is, these organizations are now trying to take care of their own internet access. Now, whether they actually outsource to a reseller, systems integrator, whatever else, they're no longer going to the ISP and say, give me everything. They're multi-homing. Yeah, we know how multi-homing works. We get a router, we plug into cables, and magic happens. Well, unfortunately, it doesn't. There has to be a lot of skill set and knowledge about who you're connecting to, where they connect to, and all the different technical politics and real politics that determines how your connectivity actually works. So an organization taking this on is taking on quite a lot of challenge, quite a lot of risk. Because now they're no longer just going to their upstream provider and say, fix it, make it happen. They're actually dealing with internet exchange points. They're doing private peering with maybe operators, more likely content providers, as well as trying to deal with transit relationships. So these enterprises are taking on a lot of the roles that the provider used to do. So what do they have to do? They have to have the right resources, so IP addresses, v4, v6, AS numbers. How do they get those? How do they manage those? What happens? What do they have to do? They have to manage the peers. They have to be aware of the costs, what the costs are, where the costs are. Who do they peer with? You can't just turn up and peer with somebody or any old thing. Different peers matter. Different peers give you access to different things. And then what are all these peering fora things that pop up at all these different events? Do I need to go to a peering forum now? What happens at one of those? What are these peering personal things that go on? Is this kind of like speed dating for internet service providers? Well, I mean, the answers to all this is yes, but newcomers aren't aware of what's going on. And so it's bafflement and bewilderment when they see a lot of this. So there's a lot of things to learn. And so what the toolbox is trying to do is give guidance to folks about where they have to start with this, who to speak to, what the best practices are, and how to deal with network outages and general troubleshooting. So the project's been underway actually probably for 2-3 years now. But this year, it's kind of interesting, the pandemic's not finished, but we're kind of heading back to normal. But really, it's now we're starting to push forwards to make, I suppose, proper content in the peering toolbox itself. So it's not a top-down thing. This is very much for the community and put together by the community. And so I've been involved in helping with a lot of the content probably for the last 6 months or so. Really to try and pull together a lot of the content that's out there, a lot of the best practices. A lot of this actually exists, and a lot of the presentations in fora like this, which is kind of, it's the knowledge that flows around, but nobody really documents anywhere. To really try and provide a learning structure and a repository for best practice info for a lot of the newcomers to the industry. And really sort of trying to make the toolbox a reference guide. I'm not trying to make it the one and only place to go to. There's a lot of really good information in many places. Many of the exchange points have their own archives and learning facilities for their members. What we're trying to do is combine a lot of this with the support of a lot of these entities to make a global, I suppose, facility for everybody. So a lot of good work has been done. I've really been going around taking a lot of the content that I've accumulated over the years to try and add this in. A lot of input from a lot of friends and colleagues who've been contributing to this. And really what we're going to try and do after the initial website is up and running is, of course, make it available globally, publicly, and then really asking you to try and share some of your experiences, best practices. We can't do one size fits all for a lot of the peering and interconnect advice. Every situation is different. Every country, every economy has different interconnect requirements. You know, enterprises are all different sizes. They have some just connect in a single location. Others have got multiple locations. All the different content providers have different ways that they like to interconnect with you and so forth. The website, I had hoped that we could get the website ready for APNIC 54, same as EPF, European Peering Forum, has been happening at the moment as well in Europe. And we had a hope to be able to demonstrate the website there as well, but I don't know, I think I ended up being a little bit slow in getting some stuff put together. So it should be in the next week or so, we can actually make it go live. There is actually a website there, but that's very outdated, just a kind of pilot of what we're trying to do. So it should be launched very soon, I hope by the end of this month. And the way we're trying to construct it is not just have screeds and screeds of text that makes it very boring to read through. We're trying to do short sections of relevant information so that it's hopefully will be easy to search, find info. So if people are trying to look up particular topics, they can find that information quickly and easily. And then put in linkages to other repositories and other places of useful information. So I've got some snapshots. This is just from the development website. I just grabbed those over the last couple of days just to give you some idea. So this is what the website's going to look like. I mean, this is just from the platform itself. So we start with like this, but again, trying to make it clear, everything can click by buttons to try and figure out where to go. The effort has been to populate the beginner section at the moment. So this is for newcomers to how peering and interconnects actually work. Intermediate, we're going to accumulate some of the more tricky subject areas, the more difficult subject areas. And advanced is really for all of you to try and give us some feedback, but some of the really interesting cases that you've come up with, some of the good advice about how to do things, where to do things, troubleshooting and so forth. So I just click through the screenshots. So we're trying to make, and all these that you see there are buttons that can be clicked on that will then open out into different pages like this to explain different topics. You know, and so it's really once this goes live is looking for your feedback to try and improve things or go, oh, no, Philip, that's not right. You know, it needs to be done this way, or maybe this language should be changed to something like that. You know, I'm not trying to make it as this is how it is and there's no other way. You know, we need to try and capture as much as we can. So rather than a live demo of a website, screenshots from the web development platform, but hopefully by the end of this month, I'll be able to show you something a little bit more. And so once that goes live, we'd love to have your feedback. Love to know a little bit more about how we can improve this so that hopefully by the time Apricot 2023 comes around in February, we'll have something that's actually fairly fully populated, and then we can work with the peering community to add more bits. So if you're interested in having a look or want to contribute some of your stories, you know, we're going to put blog posts on there, or interviews, video interviews, or if you want to contribute any content you've got, or help write some text or draw some diagrams or whatever else for some of the more advanced peering and interconnect topics, your own experiences, we'd love to have those, because all those experiences will help other members of the community globally with their journey as well. So the email list is there. Otherwise, you can get in touch with me. I wander around from time to time, so feel free to get in touch. And that's about it. Is there any, I don't expect there'll be any questions, but if there are any questions, otherwise. Okay, I can run away.
So just one question, okay?
One question.
Yeah. So you mentioned this pairing toolbox.
Yes.
Pairing toolbox is focusing on the beginners or newcomers. So just started to work in our industry. So, but there are very useful web pages and tools in our industry already. So we have Pairing DB and XPDB. So and they have a Looking Glass and the also Pairing Toolbox. So the do you have any good idea to use very well? So combination of multiple tool and website for beginners or newcomer?
Well, I mean, you know, like Pairing DB, IXPDB, and so forth are all referenced and explained because, you know, again, somebody who's relatively new to this, they don't know what Pairing DB is. And so, you know, there isn't any intention to try and integrate everything together. What we want is, this is really our starting point for people to use, where they can find out about all the bits and pieces that are needed to put everything together. So that's the beginner's side, but we also want or would like folks involved already, you know, whether they're running exchange points, and, you know, a lot of the need is coming from exchange points to say, yeah, we've got these new members and they don't know what BGP is. They think they can just come and plug in and magic happens. So it's really trying to handle those folks, but it's also those who already started the journey, involved in the journey, to have a better interconnect experience. So pointing out, you know, all the other infrastructure that's available that they need to be aware of. So that's really the goal of it.
Yes, so actually, so learning something new is very important for everyone. So this project is very good for everyone. So not only newcomers. So the other question or comments? Yes, please.
I think this is not what... Hi, Nico, ETH Zurich. When I got introduced to the word of peering, I was fed the peering playbook by, I think, William Norton. Maybe now this is a bit old, but how does the content that you provide relate to that, and what changed in comparison to that? I think that was from 2008 or something. Yeah. No, I mean, exactly right. I mean, Bill's work was, you know, all the peering work that he did in the late 90s, early 2000s, so forth. So yeah, and this is accumulating a lot of, I suppose, general knowledge that we all have, just really on a public website. So it's not trying to redo work like, for example, Bill has been doing. It's really just gathering our knowledge, everything that is not written down, the best practices, the experiences, and so forth. So it's just a supplement to everything that's gone before. Absolutely.
Hi, Philip. My question, sorry, I'm from APNIC community trainer. My question is regarding the name. Why Euro IX? Why not Asia Pacific IX or World IX or something like that?
Because Euro IX started the project.
Right.
I don't know. Bijal said, Philip, please come and help me do this. EuroIX board said, we need this, because of a lot of demand from the members of EuroIX. So, which is why I'm here. But it's not limited to Europe. It's like it's a global effort. As you probably know, EuroIX was the first Internet Exchange Association globally. And EuroIX and others, we helped spin out APIX here in the Asia Pacific region. And of course, now globally, there's the IX Federation, which is the federation of the different IX associations. So anyway, can I go now? No.
No. Hey, Philip. Yeah, but yeah, I think what you said is exactly right. Like, this isn't a competition about who does what. We all do our part. And thank you a lot. This is really important work.
Thanks, Sander. Can I go now?
Thank you. Thank you, Philip. Thank you for great talk. So, thank you. So the next speaker is Nicola. The title is Scion Interdomain Routing Architecture. So it's something new for interdomain routing. So please speak.
Yeah, thank you, Masataki, sorry. Well, here you have another guy from Europe. So hi, this is Nicola from ETH Zurich and the Scion Association. And today I would like to, sorry about that. I would like to take you through the journey that basically led us from early research about this architecture to deployment and so on. And this is joint work together with the research team at the University of Magdeburg and the research team of Professor Adrian Perrig at ETH Zurich. So let's get started. So when you look at the application layer today, I mean, there's lots of innovation. People talk about VR, metaverse, and so on. And the reality is that while there was a lot of innovation on the upper layer, when you look at actually connectivity, well, these applications then demand very stringent requirements on connectivity in terms of performance, latency, and so on. And this is very difficult to achieve because when you look at the lower layer on the internet, this is quite difficult. So let me give you an example. Here you have an extract of one of Microsoft Azure SLAs. And basically what the cloud provider is telling you is that when it comes to basically availability guarantees, they cannot do anything in cases of force majeure. So for example, in case there are natural disasters, wars, and failures between the data center and the end host, then they cannot guarantee the service. And why is that? Well, basically, that is because neither the cloud provider, neither the end host connecting to the cloud provider can do anything if something goes wrong in the network in the middle, or at least they cannot do anything very quickly to react to a failure. And so why is that? And why this is very hard to fix? Well, when you look at the internet layer and try to do some innovation in this space, you face a challenge. And this is pretty much like the challenge that people faced when they created the first fax machine. So if you create a new technology to communicate to others, well, if you're the first one to adopt it, who are you going to talk to? And this becomes very difficult. So when it comes to the internet and introducing innovations into this layer, this has been notoriously very difficult. You need to deploy sometimes new hardware, new software. People need to get used to new processes. And this is why efforts like, for example, BGPsec or even DNSSEC or even IPv6 took quite a long time to deploy. And this is because it is really important to provide some kind of incentives to the early adopters of these technologies. So in this talk today, I want to take you a bit through the journey that we faced with Scion, which is an interdomain internet architecture. And as the research team and I are from Switzerland, well, I want to use a metaphor with mountains. So changing this is a very big effort. It is a very long walk. It is a path that is quite hard and steep. And that's why we're going to take it through steps. First of all, when you get started, you need to make sure that your idea is somehow providing some kind of incentives for the early adopters, so that you can get somebody to try it out. And this was actually quite challenging, really, to move the project from research to early deployments. Later on, once you get these early deployments on, it is very important to get, at the same time, some entities using your technology, so some early adopters. And on the other side, you need to have some ISPs that are basically providing the service. And this is a bit of a circular dependency that you have to break. And then when looking at the long term, it is important that there are also some incentives in the long term so that the technology can be adopted on a wide scale. So what are we talking about? Well, we are talking about Scion. Scion is an interdomain internet architecture. It is path aware, so that is really based on end-host path selection and path segments. And so in Scion, you have a control plane that is responsible for basically discovering and disseminating routing information. So here on the right, you see an example. You see around 19 autonomous systems, and they're all grouped in 3 isolation domains. Each isolation domain has its own, let's say, isolated routing plane. And within each ISD, we have a set of core autonomous systems, the ones that are in the gray bubble, that are responsible for communication from one ISD to the other. And so on the data plane, when you want to communicate to another Scion entity, the data plane is basically querying this control plane, getting some paths, and then it combines those paths into an end-to-end path. This path is then put into the packet header, and that means that routers receive packets that already have the end-to-end path. All they have to do is to authenticate this information and then forward the packet. So that makes Scion routers stateless and relatively low overhead, while at the same time, packets are authenticated at each host. So that gives a lot of nice security properties. When it comes to path awareness, I think the nicest property is when it comes to multipath. So let's say you have a client here on the left that wants to connect to a server. You might want to have different kinds of traffic. Maybe you have a large file transfer and you want to get high bandwidth. Maybe you have a phone call and you want to get low latency, low jitter for your phone call. And thanks to path awareness that you get in Scion, then the application on the end host is able to make a decision about which path is the best suited for each application. And so that allows you to achieve better quality of service. One note about multipath, I think when people talk about multipath today, they probably think about multipath TCP or multipath QUIC. So the standard use case is that you have something like a multi-home device, maybe it's your phone, you have mobile data and Wi-Fi, and you use these two, let's say, upstream paths to connect to your server. And this is already very nice, but the thing about Scion is that you get multipath even if you're a single home. So you can really select paths even within the core network per AS, and that gives you additional benefit. And of course, that means that in the case where you have multiple uplinks, you can also seamlessly somehow combine them in on your client. So that sounds really great, but it also sounds really impossible to deploy. As I mentioned, there is this really chicken and egg problem, especially when it comes to finding early adopters. So really entities that want to deploy this. And at the same time, there is the challenge of finding incentives for people to really adopt the system. I'm talking especially about ISPs. So the good news is that we actually do have in Europe a few ISPs that today provide Scion connectivity. And so we have Swisscom, Switch, Sunrise, and a few others. And this is great. So that means that we somehow managed to break down this this kind of chicken and egg problem. So how did we do this? Well, going back to the history of the project, Scion started around 2009, so quite some time ago. There was quite a long time in early research where we had to come up with the initial model, validate it. Things also changed quite a lot in the design. And in the beginning, it was quite even difficult to find some ISPs that were even willing to test this in their environment. Luckily, around 2016, we managed to convince Swisscom and Switch, which is the Swiss research network, to deploy a small testbed. So we created Scion Lab, and this is still today the Scion global research and development environment. And that really helped us to validate what was designed in research, to come up with an initial, let's say, protocol specification that somehow worked. And the next step then was really to start getting some people to use it. So once we had the design, then we had to find some workload, some people that wanted to use the architecture. And here we get into this circular dependency. And so luckily we got a nice use case for this technology. And this is in the Swiss Finance Network, or SSFN. So this is the network that connects basically banks when they exchange payment information. They used to have a private network run by a single ISP. And thanks to Scion security properties, they were convinced to initially test this basically this protocol for building up this banking network. And one of the things that really convinced the finance industry is that thanks to Scion path awareness and cryptography, you get very strong guarantees about where your data is transiting to. So you can somehow enforce with policies that your data only stays within a trusted part of the infrastructure. And that was very important to the finance industry. Another interesting feature that helped convince them is that Scion is federated. So that means that any ISP can join the network. And even within each one of these isolation domains, there is not really a single entity that somehow owns the keys of the kingdom. The governance process is inherently multilateral, and so that also helps building trust with the finance industry. We are actually now trying to replicate this story also with the education. So we are also building a global Scion education network with some partners around the world. So there is also some entities here in Asia. So if you're from a NREN or an educational institution and want to know more, maybe get in touch and ping me. What else is important for wide deployment? Well, of course, as you get more and more ISPs on board, it is also very important to get peering. And so that's why Scion also has an IXP deployment model. And the nice thing about having path awareness and multipath is that Scion allows you to use all the IXP infrastructure, all the diversity, the redundant links, they can be made exposed to Scion clients so that you can use them at the same time. So that is an advantage versus the traditional layer 2 big switch model that is used today in IXPs. So on the more practical side, we do have a Scion peering mesh at SwissIX in Switzerland. So that is somehow independent from the standard IP-BGP peering mesh, and you can get your Scion ports. On the operational side, there is one consideration. Scion does not really have routes, so there is nothing as a route server. So there is some research going on into a tool that can help somehow automate peering configurations in a way that is somehow similar to what a route server is doing. So I think we described already how we could somehow break this circular dependency. Now, we're definitely not done yet. As I mentioned, the road to, let's say, large-scale deployment is still very long, and we still have quite some steps before we can somehow reach the summit. So what else is missing? Well, on one side, we have the community. So we want to grow this community, and this is why we are launching an industry association that basically is formed by the entities that have been deploying and using Scion. And this is really meant to promote the open source. We have an open source implementation. We want to keep maintaining it, having more contributors and so on. And on the other side, a very important piece is, of course, standardization. So today we already have 3 different implementations, and one of it is open source. And it is very important that things keep being interoperable. So that's why we have been quite often at the ITF. Our temporary home there is a Panergy at the moment. So if you're active in that community, you're very welcome to join the discussion and perhaps contribute, share your ideas and feedback. There are also some more practical issues. For example, the Cyan isolation domains have a number that has to be globally unique. And at the moment, one of the entities that is deploying Cyan is assigning those numbers. And I think this is an area where maybe some internet registries could perhaps provide some help. ISDs also have certificates and certification authorities, and they can be decided independently. But in cases where ISDs are deployed, let's say in a country, maybe also their local registries could play a role in this. So these are all open questions that I think we could discuss with the community also here. So summing up, I think we try to show that really doing some innovation at the internet layer is very difficult, but it is not impossible. We have Cyan, we have it deployed today. We have some practical experience. And so of course we have some more road ahead. And we are also very welcome to hear your feedback. So I'm gonna conclude with some pointers to some materials and resources. There's our website. We also recently published a new book, a new version of the Cyan book that describes basically how it works in detail. We also have some websites where you can do some connect to the testing network, Cyan Lab. You can run your own AS. So if you like to get your hands dirty, Cyan Lab would be also a very good resource. So thanks a lot. And I guess we can open up to the Q&A if there's any questions.
Any questions or comments?
Thanks for the talk. Richard Ma from National University of Singapore. So I think I would like to get a sense of your vision about Cyan. Do you see in the future Cyan and the existing internet will be coexisting, or maybe Cyan is going to replace the existing internet?
Yeah, thank you for your question. So I think in the short, medium term, that's definitely going to be coexisting, especially as with the early deployments, we are starting from sectors that are a bit, well, not let's say the mass internet, but it's more like finance, maybe energy. These basically industries that require a bit, they have higher requirements for connectivity. So I'm pretty sure the next deployments will be in those industries, and this will be definitely not replacing the internet long term. Well, it will be a great ambition, but I mean, there's still a very long way to go before getting there. I hope that somehow answers your question.
Hi, Sanjeev here. It's only, you mentioned the scan, there have been early deployments for about 6 years now. It's come to the IETF very late. It's only in the last couple of months that we have seen the IETF drafts. Was this because you did not see a wider use for this outside the Swiss banking community or academia?
To be honest, I think this is mostly a matter of resources. So now we are like really trying to make sure that we have time, because in the end, the IETF process is very time consuming, very energy consuming. And so from the academic research team, there were a lot of publications, but I mean, it is also not the priority of the academic community to do long-term work. I mean, of course, there were always people showing up at some research group at Panergy and so on. I think people were always here and there, but a bit more less consistently. And now we are trying to be a bit more consistent, but this is really a much bigger effort.
Hi, this is Xiaowen from Google. So you are talking about like a point-to-point connectivity, like a path-aware or this location-based routing somehow, which is quite important. but a lot of internet traffic is not from if you think about it like short videos, all those load balancer behind the services, container network, and so on. So you reach one part, then another second segment of the path, which is more important. So previously, the industry is working on the SRv6 and to achieve the similar goal here, but we don't know exactly how the SRv6 can solve this problem, or your method can kind of what's the difference between the your two methods here?
Thank you. That's a very good question. So I think the scope between SR and Scion is different. So Scion is meant to be inter-domain only, and by design, Scion leaves it up to the autonomous system to deploy internally whatever they want for the intra-domain. So they could, each AS could use whatever OSPF or SR. And the key difference of why the scope is different is that Scion has a whole set of PKI authentication tools that are meant for this to work across different administrative domains, different autonomous systems, potentially that do not really trust each other. While when it comes to SR, it is mostly designed to work inside an autonomous system, or there is an inter-autonomous system version of SR. But I think we had a discussion at the ITF about this, right, in Philadelphia. And the thing is, those autonomous systems that talk to each other on via SR are supposed to somehow trust each other. And Scion is designed for communication without this mutual trust. So that's a key difference. And on the security, there is a whole bunch of things that I did not have time to get into, but we can maybe have a chat.
Thank you.
Other questions? So, one question, okay? So, please show the slide number 16.
I think we're not getting the slides anymore.
So, you mentioned Scion inter-domain routing architecture has two typical use case model. So one is the traditional. So IXP has layer 2 switch. So the 16, I think. Yes.
Yeah.
So the one is traditional and the second is multipath. So let me move to the next page. So 6IX has second model.
So that's a good question. SwissIX, they did the deployment a bit before we did some further research on that. So they are deployed with the big switch model. So it's the basic one. And this work about the other interconnection models, it came out at, I think, last year at CONEX, but the SwissIX deployment was already done before. So yeah, they are not using the second model.
And Scion is running on the open source software or the legacy equipment?
So there is an open source implementation that is on GitHub. It is called Scion Proto. When it comes to the hardware, yes, it can run on basically off-the-shelf hardware because the biggest, let's say, intensive operation that Scion does is cryptography. But all the operations are usually based on AES. So basically you can offload it in hardware on any like normal CPU. So you don't need ASICs or specialized hardware, or at least for the basic one. There is also a very experimental P4 implementation, but well, that is much more performing, but that's very experimental.
Yeah, so that's very interesting activity. So thank you for sharing information. So if there is no comment or questions, so thank you very much, Nicola.
Thank you.
The next moderator is Pachi.
Hi, good morning again. It's my turn. Thank you, Watari-san. Our next speaker would be Dhruv. I hope I said that right. I asked him. It's going to talk about IOTF activities that might be interesting to the APNIC community.
I think I would need the.
Just give me a hand, please.
Hi, everyone. I'm Dhruv. I'm from Bangalore. I chair a PC working group in ITF, and we had a couple of talks where people were talking about ITF. So I'm giving you a little bit of introduction on ITF and how to participate and what are the new developments that's happening in ITF that I think the APNIC community needs to be aware of. So let's start. I was talking to a few people, and most of the people are aware of what ITF does, but there are newcomers in the room. So I would just quickly go over a quick introduction about ITF. And if you have more doubts, please come and talk to me. I'm available the whole week. So what is ITF? Before we jump into ITF, let's just talk about standardization. We know that, like, the standardization is important. The main reason is interoperability. We need to make sure whatever we are developing, I work for a vendor, whatever we want to develop, we want to make sure it works with the other vendors as well. So to do that, we need a body where we can go and standardize things. And those are the various standards development organizations known as SDOs. ITF is one of the main ones. It is focusing on all the internet protocols, a lot of things that we use now, email, HTTP, IP, TCP/IP, IPv6, DNS, all of those things have been developed at the ITF. So ITF has been doing a lot of building blocks over which internet works. And even in the IGF community, where some people might be from that, we always claim that RIRs, which are taking care of numbers, and we have ITF taking care of protocols, ICANN doing things with DNS. So these three organizations together take care of a lot of internet governance, and ITF is one of the key ones here. ITF is completely open. Anybody can participate. It's usually a lot of vendors, service providers, academia, a lot of folks you will see at the ITF meeting. One thing to realize, which might be a little different from APNIC, is you are an individual when we are participating at ITF. There's no membership. There are no dues. Of course, like vendors and service providers sponsor your travel, but as far as the process is concerned, it's all individual representation. The ITF sort of gets divided into areas, routing, security, applications, things like that. And then you have working groups, where each working group has a charter which clearly states what they are going to be working on, how are they going to interact with other working groups or research groups, and what are the deliverables that they need to deliver to the community. So that's how the division happens. They meet 3 times a year, physically, hybrid. Initially, it was all online, like almost all conferences. We have been running in a hybrid mode recently. And last meeting was in Philly, as the previous speaker was also mentioning about. Next one is in London. So these meetings are very important, but at the same time, the main work gets done on the mailing list. So the mailing list is anyway open all the time, actual checking of consensus, posting of new ideas. The main discussion is anyway supposed to be happen on the mailing list. So it's also a similar sort of a way how things done in the APNIC as well. In APNIC, there is a term of consensus. I think that is quite common here. The ITF uses the word rough consensus. In the sense, consensus cannot be like, full. And it's the job of people like me, like who chair a working group, to judge that consensus. And it's not voting. It's not like the majority rule, but we need to look at the technical arguments that are being put and whether those technical arguments are being addressed enough. They don't have to be changed. Nobody has a veto power per se, but that's how you judge the consensus in the room. And it's like, a good exercise in like, internet governance as well, like, how we judge rough consensus at these bodies. And ITF does care about running code. And there is a lot of hackathons. So people who are from universities, who are who want to take part, not so much at the standardization side, but at least at the implementation side, that's a very good way to participate in the ITF meetings as well. And hackathons have been quite a successful thing that ITF has been doing for last couple of years. So these are the list of areas: application, general, internet, ops, routing, security, and transport. And as I was mentioning, all of these areas are divided into working groups. I am leading one of the working groups in routing area, which is called path computation element. So I think everybody's sort of heard the name RFCs. And in fact, you might know that RFCs actually have a much longer history compared to ITF. RFCs goes back to 1969, whereas ITF got established as 1986. And RFCs are not just from ITF. You have the research community called IRTF. They also publish RFCs. You have IAB, which is the architecture board. They also publish RFCs. And in fact, outside of the standardization process, you can still publish an RFCs using an independent submission mechanism. So RFCs have a much bigger umbrella than just ITF. And RFCs are the archival documents. What that means is that once it's published, no changes are allowed. So when we have to make a change or found a mistake later on, usually you will say that, oh, I need to publish a BIS document, or I need to get a new RFC number, because once an RFC is published, it's no change. So our working documents, those are called the internet drafts. So when we propose the idea, when we are still discussing within the community, all that happens in the internet drafts. Internet drafts are simply posted. They are valid for 6 months. And if you don't refresh them, they disappear. That's what happens. So you need to continue, go and refresh and reiterate your ideas. And then the journey towards your final RFCs happen. And usually this can take a long process, as mentioned earlier as well. It's a little bit longer process, but once you get involved in it, you will get the hang of how ITF work. And for instance, I'm not a very typical ITFer, though my beard is also graying now, and I might reach that age. So ITF is much more open compared to what it used to be before. We are all trying to welcome more and more people. It's important that we diversity, as it's important in APNIC, it's important at ITF as well. So we need more voices, especially from this region. And that's my the second part of my presentation. So the chart that you guys are seeing there, this is from the last ITF. You will see USA around 40%. We have China, Germany, UK, and India doing, though, a lot more remote participation from India than in person, especially going to US with visa issues were a bit. I also was remote last time, but at least the participation is there. So from our region, it's usually China and India. Japan, that's leading. East Asia usually is doing quite well, but we, as we know, that represent so many economies, but the participation in the standard space is quite less. And in fact, especially from the operator community, I think our networks are a little different. Our challenges are different. It's important that they get represented at the ITF as well. So that's my plea with this talk as well. Looking at the continent, North America, Europe leading. Next comes the Asia. And in fact, from other regions like Africa and Latin America, the participation has been quite less. If you look at the top countries, you will see US, EU has been shown as one country. So it's sort of like combined through, but then you have China, in UK, Canada. So still participation is there from the region, but quite less. So my plea would be, why do you care? Why would anybody come and participate at ITF? The main thing to realize is the mission that APNIC has and the community here as is similar. We all want to make internet work better, and this mission applies to everyone. We care, this community cares about interoperability. We care about how to operate our network better. We care about what are the features and services that we can provide to our customers. So all of this is well aligned with what ITF does. And ITF process is completely open, but any standardization process takes give and take. There are various different things to always evaluate when you are looking at a proposal and you are judging rough consensus. And it's important for the voices in this room to be there at the standardization space as well. And that's how, when we are judging rough consensus, we have operators' inputs coming in from this region as well. One important thing is, like, why do network operators need to participate at ITF? Well, you will be aware of what's the latest things that are happening that you need to deploy. For instance, couple of years, segment routing took over, and even at APNIC and all, we were struggling with how to deploy, how would be the impact of SRv6 on a running network, and all those things were being discussed in the ITF, but the operator community got involved a little later than once the things were already moving. So it's important that the inputs comes in very early. And what happens is, vendors, people like me, are always there proposing new ideas. And we sometimes claim to say that we have, we are representing an operator, but it's important that the voices comes from the room itself. Are these the real problem that ITF is solving? Are we balancing the network operability over the new functionality? Are we going to make running your networks harder by adding this feature? All of those things are very, very important questions, and these needs to be answered by the operator community rather than vendors speaking on your behalf, right? So these things are very important. But we do realize its challenges are there. It's time consuming. People don't understand ITF culture. It could be a little bit harsher compared to other organizations. Participating in ITF requires money and long-term support. You can't just go for one meeting and get an RFC. It takes a long process. The commitment time is little longer. And sometimes even an awareness issue is there. People feel, oh, ITF is not for me, especially from academia community. You feel, oh, ITF is not something for academics. So those perspective also we need to sort of change. And people feel like whether it's relevant to network operators' point of view, like this is a vendor's playground. They are coming with new features. What are we going to do? So these are the challenges we do realize, but these can be overcome. And ITF is looking for more inputs from the operator community, and we need that. Just a few tips. I think ITF can be daunting. It's a very big area. So pick one or two working groups of your interest. You are a DNS person, look at DNS. You like BGP, look at BGP. Look at routing, security. Pick a few working groups to start with, join the mailing list, look at the conversation that's happening, look at the drafts which are going through last calls, which is just before the RFCs. Everybody's looking for inputs at that moment. So any input that you can provide at the right time, it would be welcomed. Do that. ITF remote participation has increased quite well. And like APNIC, the participation is very well. Inputs coming in from the remote community is welcome. Traveling is hard, we do realize, especially from our part of the region. So participate remotely. Everything is on mailing list. There is no registration, no this thing. Fee waivers are available for remote participation. So even free participation for remote is available. Use that. And we are here for help. Anytime, anything that you require on how to participate in ITF. There is enough community members within APNIC and otherwise who are going to ITF as well as a part of this community. One of the organizations that we started in India was focused on this, that how we can increase the participation from Indian region. And we got established around 2017. We have been doing various events. We did an IPv6 webinar series, in fact, with the help of ICIF Asia and APNIC Foundation. We do Connections event, which is our annual event where we bring in long-term ITFers as well as people from India and the region to come and participate, and lots of other things. So this organization is active in the region. Come and talk to us if you have any help in ITF participation or even awareness within your region or your organization. Now, moving to the final part of my presentation, what are the latest things that's happening at ITF 114, which was in Philadelphia? Just a disclaimer, it's not an ITF official report. I'm not representing ITF. There is in fact no liaison between ITF or any of the RIRs. All of this is my personal opinion. And there are people I see who go to ITF as well in this room. So if you guys have any inputs on what are the things that I missed, because in ITF at one time there are 8 parallel sessions that are happening. So you're bound to go to your part that you do, so you miss out a lot of things. So if I'm missing out something and people want to come and talk about something that happened at ITF that APNIC community should know about, please come and say. So this is what I divided the ITF work into key areas. The main one being operations, how to run your network, what are the best practices, what are the tools, what are the protocols that are used to run your network, various different things happening here. IPv6, we all care about it. There are important sessions in APNIC about IPv6. So there are two working groups. One is focusing only on the operation sides of IPv6 called V6 Ops, and one focusing on IPv6 maintenance, because IPv6 protocol is long standardized. So what current works happens is small enhancements to the existing IPv6 RFCs. That happens in 6-man. Routing and security sort of go hand in hand. Grow, again, focusing on BGP operations. IDR, which is inter-domain routing, focusing on BGP protocol. So again, operations is a very key part in ITF as well. You will see specific working groups only focusing on the operational part as well. Everything is not about protocol. Everything is not about adding bits on wire and adding a flag or adding a TLV. So a lot of operational things are happening there as well. Then you have CIDR, which is securing BGP, and SR work happening in Spring. DNS, we have DNS op, again, operational, as well as DNS SD, and a bunch of other working groups in this space as well. ITF meetings also have IRTF happening in parallel. There are various research groups. One of the research groups was PAN-RG, which was mentioned in the last session as well. Similarly, ITF does lots of workshops as well. There is an ACM and IRTF Applied Network Research Workshop. In fact, they have grants available as well. So for researchers in the room, you can always apply to IRTF travel grants, where you could, in fact, go to in-person ITF meeting if you are doing some research work as well. And then measurements. Of course, running your network, you need to measure. IPPM is one of the working group that does that. There is a research group called MapRG, which again does a lot of things. And in fact, Jeff is quite active at ITF, who's the APNIC chief scientist. You will see him present at IPG, MapRG. A lot of different things that you see in APNIC blocks are being discussed at the ITF meeting as well. So there is a good interactions already. We need more community members to come and participate. So let's go over a few of them very, very quickly. We have IPG. This is definitely an interest to the community here. IPG stands for Intellect Engineering and Planning Group. This is completely a gathering which happens on Sunday before the ITF meeting, focusing on the operations of the network itself. So it's completely operator driven. It's in fact established by RFC 1690. You can find more information about them. And always there is a good discussions from operators happening here. So this community you should join anyway. It's ipg@ipg.org. The mailing list is open and lots of good discussions. One of the topic being discussed was IPv6 extension headers, which I think was on agenda at APNIC as well. So good thing there. Jeff presented on Quick, his measurement on how much Quick is actually out there in the network, DNS and like RPKI, BGP-SEC, all of these things you will see at this this session. So very interesting for the community here. This was one of the topics which was being discussed called IPv6 extension header. Initial research and initial measurement by a lot of folks says that IPv6 extension headers are being dropped in the network, and a lot of people are developing new extension headers. For instance, in the session today, there was Amaya who was talking about PDM, which is the performance and diagnostic metric, which is a destination option IPv6 extension header. But if this extension headers are being dropped randomly in the internet, of course, adding extension header doesn't help. So we needed to find out and deep dive where the drops are. Are they being dropped at CDN level? Are there firewalls which are removing extension headers? What are the best practices with respect to IPv6 extension headers that should be out there? So this is a very interesting work that's happening in V6 Ops as well as in IPG. And if this is something that interests folks, come and talk to me as well. I can make introduction. In fact, I'm a part of the team which is doing this work. In fact, this is sort of new work that has happening in the BGP world. It's called intent-based routing. The idea being that with 5G and other things, we would need multi-paths. Some of the paths are more delay sensitive. Some might be more bandwidth consuming. So we need to have awareness of paths and attaching intent to the paths. And using coloring concept, which was there in BGP already, but enhancing that to support multi-domain coordination of each other and assigning colors and using SR policy colors along with BGP color to do end-to-end intent-aware routing. Requirements draft are already adopted and they are being worked on. In fact, there are 2 competing solutions from multiple vendors. Right now, both of them are being worked in parallel as an experimental work, and it will be the operator community which can come and tell us, by the way, we prefer this thing over the. Otherwise, it looks like a standardization of both the solutions might happen, which is in some ways not too good. We prefer if there is a single solution. Otherwise, like, all of us end up implementing multiple and then interop becomes much harder to do. So there are a lot of ways where the input from the operator community is needed. And I wanted to highlight one of them here. MPLS header, MPLS working group. MPLS header has been there for a while. It's standard, but now new innovations are being happening in MPLS header as well. And the work here is called MPLS network action, sort of like IPv6 extension header in some way. That's sort of what if the packet carries more data. And apart from label information and just the tiny little MPLS header that I have, what if I need to know more network action that I need to do at various different hops? So things like IOM, like more measurements, intent-aware things like, for 5G, that kind of information, if I start putting in the MPLS packet header itself, that is a new set of work. It's very important, will have a very big impact on the industry. That's a new work that's happening in the MPLS working group. Another working group that I want to highlight, we all know 5G and Itf network slicing is a very hot topic. In ITF, the work is happening in T's, where the idea is how to slice the ITF network so that we can meet various different requirements that are coming from the 5G world. Again, a lot of architecture work, as well as the YANG. YANG is the way in which ITF develops model that are used to connects between the controllers as well as from controllers to devices. So all the standardization work of YANG that's happening here. Some of the other hot topics which I've listed: application and network working together, deterministic networking, oblivious HTTP, greed networking. These are some of the new topics and interesting things that are happening here. In fact, quantum was being talked about in our plenary as well, and quantum is the new work that is taking place as a research work in IRTF as well. Like APNIC, we also have BOFs. BOFs are how a new working group or new work is introduced. Some of the ones I have listed here: stub networking for IPv6, how to do auto configuration for home networks. That is one. Source address validation enhancement to URPF. That is happening in SAVNet, which is in fact a new working group already established. How to do segment routing and multicast. That's happening at a new BOF MSR6. Security work, secure asset transfer, a new proposal. Another one is digital credential transfer. Again, like from my mobile device to your mobile device, if I need, not by giving passwords, if we have a protocol to digitally transfer information, that's again a very new work. And bunch of things, and you can find all of this information here. I unfortunately was not there in the ITF, so this was me. ITF was happening in Philly, and multiple sessions and multiple this. It's fun still to attend remote. I'm planning to be there at the next ITF, which is in November in London, and I hope to see some of you there. Thank you.
Thanks, Dhruv. sorry to show you the remaining minutes, but please stay there. Do we have any questions for Dhruv? Okay. Oh, John.
No, it's not. Next presenter.
Okay. Okay. Thanks, Dhruv. Thank you.
Thank you. I think I should remove this for you.
Hello, Jonathan Brewer. Can I have my slides, please?
Yeah. Sorry, I'm going to introduce Jonathan. Yeah. He's going to give us interesting insights in Asia Pacific subsea cables. Thanks, John.
Okay, so this talk is about a realignment of submarine cables in Asia and the Pacific. And this is a map of fiber cables in Asia Pacific region. And this is my own interpretation of the importance and competitiveness of routes in Asia Pacific. And we can see right now that there are a few important parts of the Pacific, and those are Japan, Guam, Hong Kong, and Singapore. So I'm going to talk about three cable projects in detail, and then I'm going to talk about three more cable projects in a little bit less detail, and I'm going to go through this very quickly because we don't have enough time. But first, I'm going to talk about the Solomon's Oceanic Cable Network, an Asian Development Bank-led project that was approved in 2012. And when I visited Honiara in 2014 for PACNOG, the CEO of Our Telecom told me that he'd have a new cable the next year connecting to PPC-1. And this was pretty cool. The plan was to have this cable operate as a spur of the PPC-1 cable between Sydney and Guam on what they were calling branching unit 5. So here's the design for that cable, and here's the physical configuration of PPC-1. And what do you see missing there? Branch unit 1, 2, 3, 4. Oh, there's no branch unit 5. Oops, that is not going to happen. So things didn't happen for a couple of years, and in 2017, the Solomon Islands government made some new friends. They changed around the cable project and awarded it to Huawei Marine. Huawei came along with some finance for the cable, which meant that they no longer needed the finance from Asian Development Bank, and that agreement was terminated. So they planned to kick off this cable. July 7th, 2017 was the announcement, and very, very quickly, Australia turned on the media backlash, and there were news articles and television articles and radio interviews about how it was an absolutely terrible idea for Huawei Marine, who had just built a wonderful cable system for Indonesia called Palapa Ring. Anyway, the Australians didn't like this idea. So August 19, 2017, the backlash started. There was some analysis later that said having China involved in a cable project that touched Australia was a red line that Australia would not cross. So a year later, after a year of pressure from Australian government, the Solomon Islands drops the Huawei contract and signs on Australia. So what happened here? Australia actually decided that they were so opposed to China being involved in a cable that they would rather give away a cable. So this is the Coral Sea cable system. 2/3 owned by Australia's Department of Foreign Affairs and Trade, 16.5 by Solomon Islands Submarine Cable Company. And this cable project was extended to connect Papua New Guinea. So PNG Dataco with another 16.7% there, a 5,000 or so kilometer Y cable. So you can get from the Solomon Islands to Sydney, and you can get from Papua New Guinea to Sydney, but you cannot get from Papua New Guinea directly to the Solomon Islands. And there's a bonus 700 and so K domestic cable in the Solomons, which will really help bring connectivity beyond Guadalcanal and into the further islands. So June 20th, 2018, the Australian government announces that they have awarded this project to Vocus, and another little while later, Vocus handed this over to Alcatel to build the cable. And another year later after that, Vocus completed the Coral Sea cable, and then it took another year for this cable to be turned on and used by the respective governments, but there it is. So the second cable project we're going to talk about is the East Micronesia cable system. This was a World Bank-led project. Now, World Bank is a development bank. Development banks exist to provide low-interest loans to developing economies to help them build infrastructure that they need. Sometimes when a low-interest loan is not going to make a project work, they also come in with grants. So this cable project was planned to connect Pohnpei in Federated States of Micronesia to Kosrae, Nauru, and to Tarawa in Kiribati. And they planned to get out to the internet through an existing cable from Pohnpei to Guam called Hantru 1. Now, Hantru is a cable that, in addition to connecting civilian networks, also connects U.S. military bases in Majuro to U.S. military bases in Guam. So it is a little bit sensitive for them. Anyway, it was a $73 million project, and it was put out to bid. And Alcatel Submarine Networks, Huawei Marine, and NEC all responded with good proposals. And so by 2017, they were really stepping up the promotion of this project. And they did environmental studies, and they designed how the cable route was going to be run. They designed how the landing stations were going to be put in place. And then in 2018, the Asian Development Bank joined to support the project with additional loans. And then again, more media and more promotion of the project. They made some nice videos. It really is a very important project, or was a very important project, and was really going to make a change for these countries. And then everything went quiet for some time. So here we are 2 years later in June of 2020, and the very first whispers of something wrong with this project came out in, what is this journal? This is Asahi.com. So a Japanese newspaper that has some English language articles. This was all we heard for a little while. And then by December of 2020, staff on the project began to leak to the press, in this case Reuters, that the project was being killed because the US government was putting pressure on Federated States of Micronesia, who are a country in free association with the United States. They were putting pressure on FSM to kill the project because Huawei was going to be announced as the winning bidder. Again, same thing, by January, it had hit more media outlets, January 2021. And by June of 2021, the project was officially canceled. So this is just a little over a year ago. Huawei Marine Technology was in a strong position to win the bid due to the terms overseen by the development agencies, promoting those wary of Chinese involvement to find an expedient solution to end the tender. The expedient solution was just basically to kill the project. Now, by December of 2021, there was a Christmas present from the US government this time, with the support of Australia and Japan, to fund a cable. So instead of loans, again, as in the case of the Solomons, the Western governments here are going to pay for the cable entirely, as long as their choice of companies builds the cable. So final project here really has an impact on our friends from the Philippines. This was the Pacific Light Cable Network. It was launched in 2015, a project to connect LA with Taiwan, Philippines, and Hong Kong. And it was a really neat design. It had this terrestrial segment called the Luzon Bypass. And this was to provide a path that would survive an earthquake in the Luzon Strait. I don't know if any of you remember back to 2006, December, there was an earthquake and Asia got cut off from Europe for quite a long time. It was around Christmas, and I happened to be in Europe operating a network in New Zealand. And it was very unfortunate the way that I had to hop from network and network to get from Europe back to New Zealand to actually get any work done, because so many things were broken. Anyway, Luzon Strait is a very fraught area geographically, geologically, I should say. And so they planned this cable to be resilient by having a terrestrial secondary path. Google had the landing rights and pairs to Taiwan, Facebook to the Philippines, and an interesting group called Dr. Peng had four pair that went to Hong Kong. So they started building this cable very, very, very quickly, and maybe more quickly than they should have. But landing in Hong Kong in October 2016. Sorry, the actual landing was in 2018. But this landing actually happened before they had permission to operate a cable that was going to land in United States territories, meaning California. So by August of 2019, with the cable actually almost complete, there were national security concerns about this cable, and they still didn't have permission to operate. And then this media release in September 2019 basically spelled it out and said the cable project was doomed. It was not going to go through because the FCC has denied the license for the cable to operate. So this is a cable that's built, probably hundreds of millions of dollars worth of trans-Pacific cable with landing stations and agreements for the Philippine government to have a lot of bandwidth on the cable, to operate the landing stations in the Philippines, to operate the Luzon bypass, and so on. So this is a complicated political situation. Yeah, by February of 2020, the media was saying Google and Facebook are turning their backs on the cable. They're giving up because it was politically toxic. What do Google and Facebook not want to do? They don't want to piss off the US government. So here we interject with the final destination of this cable here. In December of 2021, Team Telecom recommended that the FCC grant Google and Meta licenses for this cable. Now, who's Team Telecom? Team Telecom is a group of a dozen US government agencies. It was an informal organization before 2020. In 2020, it was codified by an executive order made by Donald Trump that said, this is the group of agencies which every cable landing in the United States or United States territories must approve before the cable is given a license to operate. So they did approve the cable to operate, but only these red segments. So the red segments that touched Hong Kong all turned off. The only segments that are allowed to operate are the cables from California to Tucheng, Taiwan, and the cables from California to Baler, Philippines. And that's it. Afterwards, the Dr. Peng group sold their shares to some Canadian family. I have no information on this. Anyone who wants to tell me the story of this, please find me and tell me the story of who now owns the rest of Pacific Light Cable. Now, about that delay, this is funny. This is a blog post that Telegeography made in February of 2020, which kind of failed on every point. They really got it wrong here. They said, you know, there's a delay, but it's really going to happen because there are several submarine cables that already connect China and the United States. PLCN is not the only planned cable between Hong Kong and the US. There's 3 other cables all in progress: HKA, HK Guam, and the Beta Bay Express, backed by big companies like Facebook, Amazon, China Mobile, China Telecom, Google, China Unicom. Big projects already underway that are going to connect to China. Well, they got it wrong. Now, here is a list of all of the submarine cables in the Pacific that have landings in US territories. And the last time the FCC approved a cable that landed in both the United States, because that's their remit, and had any sort of Chinese involvement, Chinese carrier involved, or Chinese or Hong Kong landing, was 2017 in the Obama administration. There has not been any approval for a cable, a US touching cable since Trump made it to office. So what happened? So those other 3 projects that I was going to talk about here, HKA, Hong Kong America's Cable, launched in 2018. Eventually the application was withdrawn because the US government didn't provide permission. Hong Kong, Guam. This was supposed to create a ring for RAM Telecom that would combine up with CUS and HK America, launched in 2017. NEC was actually awarded a contract to build this cable already. And by November of 2020, knowing that they were not going to get permission to land, they withdrew their FCC application. Now, finally, we have the Bay to Bay Express. CMI, Facebook, and Amazon from California. It was going to come all the way to Singapore and to Malaysia too, with a stop in Hong Kong. Anyway, they applied for their landing permit in 2018, and they actually started work on the project. They did their landing in Los Angeles and their landing station and so on. Withdrew the application in 2020. They resurrected the project as Cap 1, so a cable that reused the US landing station, the US cable segments with a new path to the Philippines. So that was the end of that. So what's next for cables in the Pacific? This is a very complicated environment. Well, we've got 3 cables here, Apricot, Echo, and Bifrost. And I've got the consortium partners for each of these cables spelled out here. What's going to be happening to these cables? Well, look at this. We've got this some number of dash lines. How many lines is it? 5 dash, 7 dash, 9 dash? I don't know. We've got this territory that that China considers their territory, the South China Sea, and none of these new cable projects actually cross that path. None of the consortium partners that we saw on the previous page have any relationship with mainland Chinese or Hong Kong companies. We've got Echo, we've got Apricot, and we've got Bifrost, and they are all going to the south of the Philippines and straight through the middle of Indonesia, and they are coming up to Singapore and landing in Singapore. So this is the state of the new cable projects in the Pacific. So I see in 5 years' time a complete reconfiguration of the importance of cities in submarine fiber transit in Asia Pacific. I see Manila and Taiwan becoming highly competitive routes, but stub routes. I see Hong Kong becoming more of a niche location. I wouldn't see anybody building any new data centers or new submarine cables to Hong Kong. I see Singapore becoming very, very, very important, and Guam continuing to be important. So, so that's my view of what's happening with submarine cables and politics. Right. We've got 3 minutes for questions until the session ends. Otherwise, you can find me afterwards.
Yeah. Thanks, John. I don't need to stay. So someone's coming.
Ulrich.
Go ahead.
Ulrich, good to see you.
Good to see you, and thanks for a great talk. I must say I haven't really paid a lot of attention to what's happening in the North Pacific, but your talk actually points out a lot of the things that I think are wrong with the way that cabling is done in the Pacific generally. It's all individual one-off projects. There is no strategic planning coordination. There's nobody who's having an oversight or putting in an opinion or going and shoulder tapping people and saying, hey, you know, we ought to be doing the network this way. And then you get all those projects that create endpoints, but not transit points. You get all those projects where people need to go around hand in hand fundraising, to ADB and heaven knows what, because, people want, connectivity, but they want connectivity as an endpoint, not as a transit point. And we're essentially creating, especially in the South Pacific, we're creating a tree topology, right? And a tree topology makes it very, very expensive for the endpoint, because essentially if they don't want internet, nobody's going to pay for them to get it. And if they want internet, they need to fundraise. But nobody is looking at the benefits of what a mesh topology would give us. For example, shorter cable routes you could run with unrepeated cables in a lot of cases would bring the overall cost down. And we're basically not seeing this sort of strategic oversight. And then there's all this politics that you've been, been going to, and politics happens, when there's no coordination and when there's no sort of transnational organizations coordinating stuff. And this is the one thing that really, really riles me with the, with the cables in Pacific. It's all those one-off projects that get planned, get complicated, and fail.
These are all very, very, very valid points.
Yeah.
The history of submarine cables has always been private commercial organizations taking the risk. In the Pacific, we do have some problems with jurisdictions. We could have mesh topologies. However, governments like Fiji do not allow foreign carriers to peer in their country. They require anybody terminating traffic in their country to have a local telecommunications license. We see this in all of the more restrictive regimes in the world. And this is why places like Singapore are the center of peering, because the Singaporean government makes it easy. Again, Hong Kong did make it very, very easy for foreign carriers to come and peer. Australia and New Zealand, the same. But it is definitely not the same in Fiji, in Samoa, in French Polynesia, for example. You cannot just come as a foreign carrier and peer your traffic there. You need a license from the government. So
What if
these are all politics problems to solve.
What if you didn't come as a carrier, but as an international organization that's having, in its statutes, a goal of wiring up the entire Pacific? Would that change something?
That'd be a great idea.
Yep.
Fantastic. Let's talk about it at PACNOG.
Yep.
All right. Shall we finish up?
I think Barry has
another
one
one.
more.
Yeah.
Barry Grieve from Alchemy to the question there on international groups. Been there, done that, tried that. That's an APEC-TEL constant conversation over the years and a PEC conversation for PEC-TEL. So there's two organizations in Asia Pacific that constantly been talking about that for 25 years and longer, right? So go to those meetings.
All right.
Thanks. Any more questions?
Thank you all for
Well,
being a great audience.
Well, I have an insight to that. It's
Yeah.
kind of the other way around. So from where I'm coming from in Philippines, so the scarcity of cable facilities going out actually more or less push internal communities and networks to have their traffic localized instead of bringing out. The idea was before is for them to be an ISP-like concept where they need to connect outside, where in fact there's a significant or huge amount of traffic that just needs to stay in the country.
That is correct. The Philippines could be a hub for submarine cables in the Pacific, and that would just take a change in how the government issues licenses. If the government issued licenses to any comers to create submarine cable landing stations, if they allowed other organizations to build their own cables in the Philippines, aside from a select few, wow, boy, the Philippines would be an obvious choice for a hub. I hope that happens someday.
Well, they opened up foreign ownership now.
All right, good luck.
Yeah.
Thank
Thanks,
you.
John. Give it a hand, please. I'll pass the mic to my colleague. Do you want to give the speaker some tokens or no more? Okay, I think the session is over. Thanks again. We'll just request the speakers to say for some tokens. Thank you.